Okay, so now we're going to talk about reflections, and we've done all these transformations before on other types of functions. We're just specifically focusing on the exponential functions, and it's a good review. Okay, so we have two types of reflections. It can reflect about the y-axis, or the x-axis. Okay, so when the negative is in front of the function, in front of the parent function, that's going to reflect about the x-axis. So think about your parabola and turning it upside down. Okay, so we'll show you what this looks like. If I have a table of values here, and let's say, need a little more room. Let's say f of x is equal to negative 2 to the x. So our parent function is 2 to the x. 2 to the x. And then we're going to go ahead and use negative 1, 0, 1, 2. And then if we put those in, we've been doing this for a few examples, we get 1/2, 1, 2, 4. And we can graph that. And it looks like this. And we could pick more points for this example, but I didn't. Now, what's going to happen is we're going to take, for our f of x, we want the opposite of all those outputs that we have in orange. So it's going to be negative 1/2, negative 1, negative 2, negative 4. Now, when we graph those ordered pairs, negative 1, negative 1/2, 0, negative 1, 1, negative 2, and 2, negative 4. So let's see what happens here. Negative 1, negative 1/2 is going to be down here. Whoops, not there. I'll have to erase that point. Okay. And then we had 0, negative 1, and 1, negative 2, and 2, negative 4. So now it has reflected about the x-axis. This is going to change some things, not everything, but the domain will still be all real numbers. The range, though, the range is going to go from negative infinity up to 0, okay? Because it's coming up this way, right? It's below the x-axis. And the asymptote, though, is going to stay the same here. So it'll still be y equals 0, okay? So that's that one. Now, my other function I had was, g of x. Now we're going to do, I think I had b to the negative x. Well, that's the same as 1 over b to the x, right? So it's the reciprocal. So you could look at it either way, but this is going to reflect your parent function about the y-axis. Okay, so let's go ahead and have a parent function. I'll make a little chart here. And we'll be graphing f of x equals 2 to the negative x, which is the same thing as 1/2 to the x, which we've already graphed, but I guess we could pretend we don't know that. So here's our parent function in the middle, and then we're going to be graphing f of x. Okay. We're going to still use negative, well, actually, we like to use negative 2, negative 1, 0, 1, like that. Okay. Now, you could pick other numbers, and you would see what you need to do. For the parent function, you have to go back in your memory bank here a little bit, but the parent function, when you put in negative 2, it's going to be 1/4, and then you're going to have a 1/2, and then you're going to have 1, and then you're going to have 2. But now all of those are going to reciprocal because of that negative in the exponent. So I'm going to get a 4 here, a 2 here, a 1, reciprocal of 1 is 1, and a 1/2 there. So that might be a little bit tricky to understand. You might want to go through the table of values a little bit more. And there's better pictures in the book too, but this is just my drawing. Okay, so what does our function look like then? Negative 2, 4, 1, 2, 3, 4. Oh wait, let me put the parent function up just so you can see it. We've been working with that same parent function for a little bit. Okay, now we'll graph it. So negative 2, 4, negative 1, 2, 0, 1, and 1, 1/2. And then you can see that it reflected about the y-axis. So what does it mean for the domain and the range and everything? So the domain's still going to be all real numbers. The range is going to be the same, 0 to infinity, and the asymptote's going to be the same. Y equals 0. Okay.